name is Nyk Lewis, and today we're solving inequalities in one variable. Here are some definitions and examples. All right, so here are my notes that describes inequalities in one variables, which is my section. So first, we have what is an inequality. So inequality is described by the less than or equal to, greater than, or greater than or equal to sign. And this is when your number on the left or right hand of your sign is greater or equal to. So for example, we had 5 is greater than 2. That means the number on the left where the alligator sign is, this sign is bigger than the 2. And this is a good way to describe the inequalities when you're solving them. So a greater than sign or equal to sign would be this. And that means this number is either greater than or equal to this number. So you might have a 5 here. So it's either equal to or greater than the number, which makes this true. So you wanted a less than, so then you would change this 5 is less than 10. And the less than sign is when the second number is bigger than the first number. And then you can have a less than or equal to sign. And this is when this might be less than or equal to. So that those are inequalities. Then a solution set is the whole set that makes the inequality true. So if you have, say, a x now, so the x is greater than 2, then the whole set would be all real numbers greater than 2. All real numbers that represent x are greater than 2. So x could be 100, 500, like any number. So the solution set right here is what makes all real numbers greater than 2. And then, all right, the next definition we have in order to solve inequalities in one variable is integral notation. And as you can see by my definition, a and b with the parentheses is all numbers between a and b, not including a and b. Then you have with the brackets, a and b, all numbers between a and b, including a and b. You have parentheses with a bracket is a comma b bracket or bracket a comma b, which includes 1 and the endpoint. So if we have, for example, all numbers between a and b not included, so you could have 2 and 5. This means that 2 is less than x and less than 5. So it's all numbers between 2 and 5, but it's not including 2 or 5. So it can be the numbers between 2 and 5, but it cannot be including. Then the a bracket with the b is all numbers including 2 and 5. So if you went here, you could add the sign what you just learned over here, the less than or equal to, and then less than or equal to. So it can be the all numbers between 2 and 5, and then including 2 and 5, which is a and b here, but 2 and 5. And the last one is the 2 brackets, all numbers between a and b, including a and b. And then we have here where it has parentheses and a bracket, which with these same numbers can mean it could be the 2 here could be less than x, or it could be less than or equal to 5. So that's the difference with this one. All right, and this last one is that it includes one endpoint. So for example, you could have something like negative infinity over 3, and it goes forever in the left side, but it ends at 3 in the right. So it could be x inequality 3. And then you can do another one. The right side, it can go forever on the right side, which is this one over here. So it can be 4 and then infinity, but then this inequality would be x greater than 4. So these basic definitions are basically explaining how you would set up your one-step variable, your inequalities in one variable. And down here we see there's some examples. The one-step equalities with variables, you see you have an x plus 3, and then it's greater than 7. And we can see how we're going to use the inverse and to isolate the x and all that, but we'll get to that later. Now we have solving polynomial inequalities, which is also a big part in this section. First, you move all terms to one side, then you factor the polynomial completely, then you identify critical points, zeros in the polynomial, then create a sign chart and divide the number. And we'll be going over examples of this later. Now we have some practice problems from the quiz that describe the definitions. All right, for the first example, 4x minus 5 less than or equal to 11. This is a linear inequality that we need to solve by isolating the variable and using inverse equations. So inverse operations. So first we have 4x minus 5. We need to get the x alone, so we do the inverse of the subtraction sign, and we add 5 to the 11. So the added 5 becomes 4x is less than or greater than 16. Then, using the inverse, so we have 4x in multiplication. Using the inverse, we divide both sides by 4. So 4 is divided by 4, which gives us x. And we bring this over to this side, which gives us 16. So the 4 divided by 16 gives us 4, which is why x is greater than, x is less than or equal to 4. And that is the answer for that one. So basically, all you need to know for this one, when you're solving these type of problems, you can locate the x and isolate it, and use the inverse equality, the inverse operation on this side, and get the x by itself, and then use the inverse operation again to get x by itself again. So then we have 4, you divide it by 4, and then get divided by 4 into 16, and that's x is less than 4. So just x or less than or greater than 4. So just get the, isolate the variable on its own, and then you will be good. Number 2 is a similar type of problem to the first one. And then first you distribute the -2 to the x minus 3, because -2 is outside the parentheses. So when a number is outside the parentheses, you have to distribute. So you distribute the -2 to the x, which gives you -2x, and then you distribute the -2 to -3, which gives you +6. When both two signs are distributed, you add. So you can have -2x plus 6 is greater than 6. So then now you have this here. So you need to get x by itself like we did over here. So you have to subtract 6, you get 0. So now you have -2x is greater than 0. Then you divide -2 and flip the sign because you're dividing by negative. So you divide -2 on this side and get x is less than 0. And now, so that's just to graph this. So we know this from all of the isolating the variables we did here. So this is the same as this, but we just distributed. So we know this from the isolating the variable, but now we have to graph it on a number line. So then we want to plot all our points. So it's up to 6. So we can go from 6 positive and 6 negative. And then the answer is 0. So you want to start at 6 and circle 6 because it's not a greater than. If it was a greater than, then you want to circle in 6. But since it's not a circle in 0, but it's not a greater than, you just want to open circle 0, which I have right here. So then it's x is less than 0. So you can do, that's basically an interval notation. That's -infinity is x because you're going that way forever. So then you can go 0 and then shade all this because it's going that way to infinity. And this is your graph here. All right, now for number 3, we have a solving polynomial inequality example. Solving polynomial inequality. So first, this is the problem. Parentheses x minus 4 parentheses x plus 2 parentheses is greater than or equal to 0. So first we have to get these to equal to 0. So you want to do plus 4 for minus 4 to get to equal that out, and then minus 2 for plus 2. So the first number we start off with, the critical points that I said from the first time, is -2 and 4. All right, these critical points that we got from -2 and 4 will help us divide the number line into 3 intervals, which will help us pick our test points. So to test each interval, we want to get the variables to be positive or 0, like we did. So we tested -3 here, we got the positive. We tested -4 here and got negative. And we tested 5 minus 4 and got positive. We tested -4 here and got a positive. So our answer was with parentheses -infinity, comma 2 bracket, and then bracket 4, comma infinity, because these two variables that we tested got us a positive. All right, so these are the last 2 examples. And we have a true or false question. If you multiply both sides of an inequality by a negative number, you must reverse the inequality sign to keep the solution valid. And this is true. If you multiply or divide a negative number, you must reverse the inequality in all times. So that is true. All right, this is the last example we have. So this one says, it's a word problem. It says you need to buy pens that cost $2.50 each. You have at most $20 to spend. Write and solve an inequality to find how many pens you can buy. So first, this is the inequality we have here. It's set up like this. The inequality we have is $2.50 x is less than or equal to 20. So then we have to divide this to get the x by itself. We divide 20, we divide 2.5 into 20. And then with this, we figure out to get x alone. And with this, we figure out that we cannot go over 8 times because 2 times 8 is 16. And then you can do 0.5 twice, 0.5 for the remaining values, and you get Thank you for watching. Now I know you know how to solve inequalities in one variable.